Hello. Well, welcome to day two. This is usually the hard day to get to at any conference, so thanks for making it bright and early this morning. Thanks to Todd for putting on a great show. So I'd like to try to start and open up today with a talk that I believe is optimistic, looking towards the future and generally believing that we're all headed in the right direction, even though sometimes it feels like we have to go backwards to get there. I put a colon here with the word automate because that's sort of a particular area I look, but that's not necessarily the only way. I don't want you to think that's the only way that I believe we can move forward, but that's what we're going to talk about today. John will give me a great introduction, but for those who may not know more about me, I'm the founder and CTO of HashiCorp. We're the creators of a number of tools, none of which I'm going to talk about today in the keynote. I'll be giving a Vault talk later today, but just to name the tools real quick, if that helps with any sort of recognition. We created Vagrant, Packer, Surf, Consul, Terraform, Vault, Nomad, and then a suite of enterprise tooling around that. So if you've ever used any of those, we're the folks behind that, and hope you've had a decent time with those. But let's talk about how I believe we're moving into the future, how automation relates to that, and how tooling and our look on tooling and our development of tooling is heading in that direction as well. And so this is a story about basically evolution and maturity, and really paradigm shifts as a concept. And I think the word paradigm shift, when people think about it, you think about it in the massive sense, in the industrial revolution sense. But realistically, paradigm shifts are happening in every shape and size every single day. And we're experiencing them very rapidly, sort of in our industry, in the tech industry, on effectively 5-10 year cycles, or if you're in JavaScript, it's basically every few weeks. But the place where I concern myself with paradigm shifts is generally what I'll broadly describe as application development, deployment, and maintenance. And so this is potentially DevOps, depending how you look at it, but it's really both development and the management of servers. And for this talk, I'm going to lean more on the management of server side, but those two things go hand in hand because developers often push operators to adopt new technologies. If you build your application with some hot new technology, sometimes there's enough pressure from the developer side to support it in your data center. And likewise, sometimes the limitations of the data center force developers within constraints as well. So it's very much a hand-in-hand process. But this has been flipped on its head a few times, depending how you look at it, in the past 20 years. And really quickly, because I don't want to go through a history lesson here too much, is just how has this evolved over the past 20-ish years. So I'm not going to put dates on here because people experience these phases at different periods of time depending on the maturity of their company. But generally, you start with one or a few servers. Very quickly after that, of course, you jump to a handful, and management starts to become a little bit more complex. At some point, data centers evolved to support virtualization, which definitely threw a lot on its head, increased complexity quite a bit. And then, of course, more recently has been containerization popping up as well, which both runs on physical servers as well as on VMs, just due to the nature of how things are today. What's more is that the rise of SaaS means that a lot of functions that used to be sort of core data center functions are now very happily being shifted off to third-party service providers. There's a lot of this, especially if you're a smaller company. Less of it, maybe if you're larger, you've been around longer. But these are things like DNS providers, CDN, load balancers, databases. It's very easy, especially as a newer company, to offload a lot of what would be considered critical data center technology off to third-party providers. And so in the grand scheme of things, I also consider this part of what is becoming more and more of an abstract word of your data center. And then also there's multi-cloud and multi-region here. And what used to be relegated only to those who had deep enough pockets to afford such things is now very, very financially and technically accessible to just about anybody. Pretty much any individual here today could make a highly available app across 2 data centers and afford it. So this obviously increases complexity a lot, but it's happening more often. And so this is sort of how I view what I call a modern data center. It's if you're building tooling for helping application deployment today, data center operations today, the tooling really needs to be built in mind to support a topology sort of like this. Support the idea that you could be running on physical servers, you could be running on VMs, you could be running on containers, it could be containers on VMs, containers on physical servers. The network may be virtual. There might be multiple data centers. You might be going across a huge WAN to another region. And all this needs to be just taken into account. Whether you support it or not, it doesn't really matter as long as you take it into account and you can understand what's going to happen. And we've gotten this far, and there's all these technological advancements, so it feels like everything should be getting better and better and better. But a lot of times it just feels like things are getting harder and harder and harder and more complicated. And I mentioned this briefly in my talk yesterday, and now I'll have visuals to support it, but it feels to me like technology and tooling follows a pattern kind of like this. I don't think this graph is exactly right, and the units don't make any sense, but I think the general feel of this is right. So in this graph, red is technology, the change of technology. The x-axis is time, the y-axis is complexity. And so technology changes over time, tooling is going to change over time, that's inevitable, it's going to happen. And what's changing during, what we do have a little more control of is the complexity of the whole thing. But I feel like this is the pattern that it goes through. And our tooling's been around for about 7 years now, so it's not super long. But even in our tooling, I felt to go through these waves. And so the general idea, as you start at, say, point 0, and you start introducing new technology. So let's say virtualization, right? Virtualization comes into the mix. It's new, and because it's new, there's not a lot of tooling to support it. So the complexity to use it is really quite high. The tooling complexity, on the other hand, is going down because the tooling is becoming simpler, but not for that technology. It's for the previous technology. It's like catching up. It's sort of delayed. I think that didn't work. There it goes. To put some arrows on this graph, basically the complexity of the technology gets harder and harder, and during this time, people are manually doing things. They're just dealing with the pain. They're just going at it because it's a new technology. They accept that there's no tooling to do it. They'll just do it manually. And at some point, you kind of reach the max pain of that set of technology, and you're not willing to do any more without a little bit of help. And this is the point at the bottom where then the tooling complexity starts coming up to deal with the technology complexity. And it does feel like there's this magic point somewhere in the middle where the tooling is about the right level of abstraction and the right level of complexity and difficulty to learn to manage the technology in a very, very productive way. And this is sort of the point where I feel like would be like a 1.0 tool. There's books published about the tool. There's comprehensive blog posts and resources to know in various scenarios how to use that tool for some technology. And this is a really nice place to be. So if you look at for sort of like the download numbers of our tools, it's really interesting because in every single one of our tools that's, say, more than 2.5 years old, the growth is fairly linear, and then it hits this one point where just instantly out of nowhere, the slope of the download numbers basically changes from 1 to 2, basically. It takes a huge shift. And I really think that that's when you reach closer to this point. That's when there's enough resources that someone who isn't willing to deal with bugs and really figuring out how things work has enough to just get going really quickly, and it leads to this explosion of word of mouth and everything that grows a tool. So after that, the tool complexity goes up because people get really good with the tool. So you start building really cutting edge features into it that the average person probably won't use, but the people that do understand give you a huge edge on the current frame of technology. But this ends up being really, really complicated, so a lot of people don't use it. And what this leads to is basically a point where your tooling is so advanced and the technology is basically mastered that people start pushing the limits and start moving to the next thing. And then that's when I think you hit the next paradigm. Is basically, and I'll show you examples of this, and this is where you enter the next flow and new tooling and new technology. So let's use an example, and this example we'll use is the proliferation of VMs. So I'll mark this as early to mid-2000s. VMs have been around a lot longer than that, but I think this is all my timelines are really when it got super mainstream, I guess. It really exploded in adoption. So during the VM proliferation, there was a few issues that took a really long time. So acquiring a server took a really long time. Provisioning a server, you had to manually start up processes and configure files and things like that. Took a really long time. And sort of a specialization of that second one. Configuring very common things like database to load balancers is the same as provisioning, so it took about the same amount of time. But you wanted more of them because VMs were so easy to get now. So that became a particular issue. And very quickly into that cycle, around 2005, 2006, oh, well, I forgot about this, but you start reaching max paradigm pain around that time, and you start getting tooling to resolve these issues. Very quickly, the tooling came out, and these are now today this time scale. So acquiring a server today, acquiring compute today, not necessarily a physical server, right? Acquiring compute today could be done in seconds. You could make an API call, and it could return you a very, very powerful machine in seconds. Provisioning something could take minutes on average. It could take longer if you do a poor job, but it takes minutes generally with tools like configuration management. And then people have wrapped all this up in specialized APIs in order to make getting specialized services like databases and load balancers seconds. And so the way this is done is basically server acquisition is through various control planes and APIs, so this turned into AWS and so on. Provisioning is just config management, which saw a huge boom in the mid-2000s. And then the databases and load balancers and so on became third-party APIs. And basically, that was at this point. That's when all of this happened, is all this stuff became readily available, and people were doing it, people were pretty happy. So that tooling was all made to basically manage this. And it did a good job of managing this. But it started reaching this point where the tooling got pretty good, and people started sort of pushing the limits, automating as much as they can with it. And I believe that this sort of pushing is what leads to stuff like this. Is it suddenly you have the tools to spin up servers really quick, to provision them really quickly, to do all sorts of fancy automation, and you start just seeing like, okay, what if we did containers really, really fast? And you start experimenting with stuff, and this is what happens. But then, and I call this sort of like the cloud proliferation, and this is really happening right now. So obviously AWS came out in like 2006, 2007, but really mass enterprise adoption, mass adoption of AWS and cloud in general is in the 2010s. Just look at the revenue numbers. And this comes with a whole new set of problems. So the previous problems are solved. We can now look at what is now our bottleneck. And what I've felt is sort of the bottleneck in this generation, among many others. There's more than this, but the ones that I've been specifically looking at are things like full data center creation. So we can now spin up individual servers really fast. But we still reached a problem where when we approach somebody and said, spin up a whole new isolated, separate like staging cluster, there's a lot of manual effort that went involved there. Then there's SAS management. So when you were just managing DNS as a SAS, it was easy enough to go ahead and click through the UI and make things happen. Nowadays, like I said, startups especially are managing probably like a dozen or more software as a service, and it's getting pretty burdensome for little changes to log into UIs and click and change things. It feels pretty old school in a way, and so you really want to automate that a bit more. There's app deployment. So when you had one big monolith, obviously the overhead of deploying that one big monolith isn't terrible for the cost, but when you're starting to get microservices and you're starting to get dozens or hundreds of applications, the marginal cost of deploying that is just way too high. We need to make deployment way safer and faster. And then there's infrastructure and app security, which is moving basically from perimeter security, where you could point at a wall, a hole in the wall in your data center and say that's where traffic comes in, to moving to this cloud model, which is a lot more nebulous, and you really, in that case, want to move to more of an app security model, mutual TLS, encryption within the traffic and within your data center, protecting against not just external hackers. But I claim all of this today can take this long, but we're still in a complex phase. So we can now get to minutes and seconds with this, with tools like Terraform, schedulers like Kubernetes, security tools like Vault. And this is leading sort of to the next thing. And I don't know what the next thing is, but I'll just go ahead and call it the app proliferation, but we'll find out. But this is basically the idea that once we solve deployment and all those problems really easily, it'll become so easy to build and deploy applications that we'll build a lot of them. And not just because we can, but because companies have to. Every company is turning into a software company. Every software company is building multiple applications. And with mobile and IoT sort of on the rise, like it's inevitable that there'll be just more and more applications that need to run on a server. And so the question really becomes, in this world, what is going to take minutes, hours, days, and weeks? Because those are the problems that need to be solved. For the entrepreneurial people, those are the problems that are going to be really good businesses to get into. And it's still relatively unknown. So I think we're about here right now, which is where we're pushing something new, and the tooling definitely doesn't support the new things, but we're heading towards something interesting. So thank you, and I'll just leave you with a quote. So thank you.